Hey guys, welcome to another episode of Introduction to C++ with your host, George Wulfers. Today, if you guys are following along, please go to github.com/gwolfers88/intro to CPP or follow the link below. And here you will be able to download, you would want to go into download this zip file, and inside of that zip file you can go into, just start the solution and continue from there. Or download it, since it'll already be completed by the time you guys get to see this video. Just follow along if you guys have any questions about it, or if you guys missed something or isn't working. Make sure you can see my code and whatever. But there's not much. Maybe we'll get to do a little program, but I am not sure if we're gonna get time for that. But we are going to cover function overloads and templates. Last time we talked about functions and what they were and different types of functions. So here I am going to go ahead and add a new project, and we're going to C++, empty project, hello world, yeah. And we are going to name this sorry, intro to C++ func overload and templates. Press OK, and we'll create that. Make sure you set it as the startup project, and let's go ahead and add a file. Let's go ahead and add a main CPP. Okay, so what are functions overloads? Function overloads is, when you have two functions. Let's call it func, and let's say int a, or okay, we'll do this. We don't need a description there. Let's include iostream and namespace std. Okay. Now, a function overload is a function. Like, let's say we have sum function and or add, and we'll call it int a and int b for the parameters. Okay, so this function, what it does, it takes two integers, a and b, adds them together, and returns the result. Now, a function overload is when we have the same function, but instead of taking integers, it takes, floats, or a different, it's got the same name, but it has different variables or parameters, parameter types, I should say, data types. So when we call this, we call add, and you see that we have, one of two. We have a float and we have an integer version. So this allows us to have multiple versions of the same function, but that take different parameters. Okay, so that is function overloading. So remember, function overloading is when you have two functions that have the same name and take different types of data for their parameters, just like these two. Now, templates. Templates, I believe, are pretty cool in some cases. So let's say we have a function, subtraction or something, and it takes an integer a and an integer b, is just like, addition. But we take a and b and, subtract them and return the result. Now, if you want to make a function that can take any parameter, like, doubles and stuff like that, and then you want to take more and more and more, you would have to make so many functions. You will have a list of, like, I don't know, as many functions as there are combinations of data types. So a faster way that you can make one function for every data type would be through a template class or templated function. Okay, so this is how you would write the beginning of it. It specifies so, and then you would do this and subtraction, and then we'll say type A and type B, and we'll actually write this function. Let's say type result equals A minus B, right? And then return that. So when we call this, we say subtraction and when you I believe you don't have to do this, like, let's say you want to make it an integer, this function, then you would do this in front of it, and then you would do let's say 10 and 20, right? So that's how you do that. Or you could do I believe you can do this as well, and it'll be just fine. It'll interpret these as integers, and then you can have, you know, other functions that take floating values. They can also take double values. They can also take char values, and so on and so forth. And if we do a printf right here, and this is D, let's just copy that and paste it everywhere. And we had this like that, just like that. And then we had this like that. And we actually have to do, for this one, I think we can just do that. For doubles, I forgot how to do the doubles. For floats, it'll be this. If you put 0.02, you'll tell it to just output 2 decimal points at the end, and then we can get char, and we'll see different kinds of output if this thing works correctly. Let's see, what am I missing? What does it say? I'm guessing it didn't like that. Access violation, relocation, ... Key. Let's do B minus, I don't know, 32. Oh yeah, you can't mix and match these like that. You have to specify it. If you want to mix and match stuff, I believe you would do this. So this would be other type, and then you do something like that. So printf to do sub, say again A subtract 32, and we'll do S and do that, and there you go. I guess that's something. So we can say that they all have negative numbers, and this one, the first one is the integer, this one, that we specified outside that it's an integer. The second one is another integer that is not specified, but because it doesn't have any decimals, it knows that it is an integer. Then we have another one, the third one, it's a float value, and we know that it's a float because of the F right here in the end. If it didn't have a float, it'll be a double, which I don't remember how to print doubles like this. Yeah, no. So I guess what I could do is, instead of saying that, we can just say cout. Well, nothing like that, just sub and 10.0, 20.0, and line, and that'll be the same thing as printf. And as you can see, now we have negative 10 as well, right there. So yeah, that is templating, or making one variation, like making one functionality with multiple types. That's what template, putting templates in your functions or classes do. Like, for instance, if we go to the if we include vector, this is a dynamic array, and when we create this guy, we specify here what we specify the type that it can be. So templating is pretty powerful, in my opinion. I have heard that some people don't like it, but I do. It's useful for making, like when you go to data types and you're trying to make a linked list that is, reusable, and you don't have to create multiple with different types. You can just create one and template it, and it'll be of any type, essentially. So yeah, that's pretty much what templating means or is. Let's see. You can also do, this and just call it n. Is it like that? Don't remember about that one. But you can also say, class something else, or not even say something else, just leave it like this, and then you can also have, like, I don't know, maybe a integer here. But now these two are like, what the fuck? BBB. So that's that. So let's make a little program that lets people add, subtract, or do stuff like that. Okay. So the first thing we are going to want to do is let's comment all this out. And actually, maybe we can just cut it from here, and I'll paste it right there, and we can do this. Okay, so I guess we can talk about something else, structure. Okay. So should I talk about structures right now? No, I'll keep that for later. So let's make a calculator, right? So we have to have, actually, int add so this is going to be we'll do that. Then we have subtract. Divide or div. Not float. So the reason why this one is not an integer is because we are going to have floating values when we divide, like to get 0.5. Okay. And I mean, we won't be able to do this, but whatever. You guys can modify it with template classes or something. Okay. So that's all for now. So let's go ahead and ask the user what he wants to do. What would you like to do? And then we're going to create right here. We're going to get an integer, and we'll call it input or something like that, and we'll make it -1 for now. And then we're going to use cin to get the user input. Okay. And then if we're gonna check if well, actually, well, never mind. Yeah, if input is greater than 0, then we are going to check and to see if we have a valid input or choice that he wants to do. This is just going to be a simple little menu. So we got add, subtract, divide. Okay, we don't need that many. It's only in 3, and we'll use default to print out something like invalid option. Okay. If we get here, then we're gonna say add. Actually, no, we still gotta tell it to enter some numbers. So here we can say and we'll have I don't know, maybe an array of we'll just call it data. We'll have 2, and we'll just initialize them to 0, and we'll say okay. And we won't really do much error checking because that will be part of a different tutorial. So if after this we'll just do result and say add data 0 and data 1, and then you can see out something like result is, and say D. Oh, you can't do that here. Result into that, and we can actually just copy this and oh, And we'll do, we'll say here that we have addition, subtraction, and division. And here is invalid input. Okay. So this is going to be blah blah blah. Subtract. And this is going to be float. Divide. And float. Huh. So as you can see, there's already a function called div in somewhere in IOStream, probably in the standard library. So one way we can get around this is to put namespaces around our code. So if we do this and we say using namespace math, we can now successfully, except here we can just say math div. Okay, so this will fix that because it'll be inside of this namespace. And let's see. Now we have to also print out some other stuff. So you can either put it like this, or you can do this to get a new line and then keep on writing here to get on the new line. But you should do that here, and then we'll tab it out. Nah, I don't think so. One is going to be addition, subtraction, division. So if we go here, we'll just say go to we'll call it prog loop, which will take us all the way up here. We can either have it like this, or we can have a while loop going around it. And let's try to run it and see what happens. Okay, errors. So whenever you get errors like this, and you're like, oh my god, I don't know what to do, go ahead and locate the first error. You can locate it by either having this, reading that part which says error, or we can go ahead and go to, is it here? not view. Sorry. View and error list. And double click on the first one. So it says initialization of result is skipped by case label. Okay. So what we can do here is cut this guy, put it back just like that. And before we go inside there, we'll just say it equals 0. That way we'll have it for every one of these except that one. So, okay. And we're getting more errors. Next one. Data is skipped. So let's do the same thing. And we can just initialize it here back to 0 just in case. And we'll do that. And we still have the float values. I believe there's a way that we can just ignore this error. Let's call this one F data because it's going to give us an error if we try to call it data again. So it goes there. And we'll call it F result. And there we go, no errors. We have successfully fixed our program, and now it wants us to pick an action. Now, I messed up the addition, so I'll close that. And they're all called addatoin. So addition, subtraction, division, and let's do addition. Press 1 and enter. And let's see, let's do 5 plus 20. And what happened? Data was corrupted. Okay. The way to fix this is to not do this, because data of 2 does not exist. It's only 0 and 1, and if we want to delete those, we either have to do a for loop. We can't just say this anymore. We have to do a for loop like right here and just make sure that data is equal to 0, but we don't have to. We'll just keep looping from there, and we'll clear it out eventually. So let's go ahead and do that again. 5, 20. 20, and it goes away. So let's do right here. We'll get car and see out. Press enter to continue. We'll do that, and then we'll just do that. And we'll have to run it every time we want to do an addition for now. So 5, 20. I see. We'll do system because I forgot how to flush that, and I think I said I was going to figure that one out, but I never did. I forgot. So 5 minus 12 is going to, 20 is going to be negative 5. 15, damn it. Boom. So there you go. That's our first little program. Now, if we wanted, while let's get a boolean, bool equals is running true while damn it, r while is running. So we're going to encapsulate this whole thing into a loop, and we are going to add one more case. So if we have 4 right here, 4, we're going to say exit. So we're going to exit this loop. 3, and right here, case 4, we'll just say is running false. Break. And well, we don't need that. And now we can just leave it like that. So now whenever we press number 4 and press enter, we are going to exit. Otherwise, we'll keep running this program. So there we go. 5 and 20 is that. And then let's say we want to do subtraction. 5 and 20 is that. Wait. Addition should not do this. Damn it. 1, 5, and 20. I just realized this. When we add, we should get 25, not that. So what is wrong with this? Addition. 1. Okay, we get add, subtract, and divide. Yes. It's because we did minus. I just realized this. Now it should be okay. 5, 20, 25. There you go. 2, 5, 20. There you go. 3, 5, 20, 0. Let's do another division, and let's say the first one. Let's do 4 divided by 2. That is odd. Ah. F result. 3, 4, 2. Still 0? What? So many errors. 3, 4, 2. There you go. So that is how we do a simple program. Now, there's a lot here we can improve on. And in our next tutorial, well, maybe not our next tutorial, but later on, we'll be adding on to this and making it better than it is already. So, thank you for watching, and if you like this video, I know it was brief. Hopefully I got my point across of what a function overload was and what templates are and what they are used for. And I hope you guys had fun making this little application with me. If you guys want to follow along, go ahead and go into my GitHub and download the zip file. And if you're having trouble, please also download it so you can see the code that is inside here. All of our tutorials will be uploaded here. Thank you for watching. Have a great weekend. Thank you.